Welcome to our lesson on x and y intercepts in functions. Understanding intercepts is fundamental to graphing and analyzing functions. Let's dive right in. Let's start by defining what intercepts are. Intercepts are the points where a graph crosses or touches one of the coordinate axes. The x-intercepts are the points where the graph crosses the x-axis. Since the x-axis is where y equals 0, we can find x-intercepts by setting the function equal to 0 and solving for x. The y-intercept is the point where the graph crosses the y-axis. Since the y-axis is where x equals 0, we can find the y-intercept by evaluating the function at x equals 0. Let's look at our first example, a linear function. Consider f of x equals 2x minus 4. To find the y-intercept, we evaluate f of 0. F of 0 equals 2 times 0 minus 4, which equals negative 4. So the y-intercept is the point 0, negative 4. To find the x-intercept, we set the function equal to 0 and solve for x. 2x minus 4 equals 0. Add 4 to both sides to get 2x equals 4. Then divide by 2 to get x equals 2. So the x-intercept is the point 2, 0. Now, let's move to our second example, a quadratic function. Consider g of x equals x squared minus 9. To find the y-intercept, we evaluate g of 0. G of 0 equals 0 squared minus 9, which equals negative 9. So the y-intercept is the point 0, negative 9. To find the x-intercepts, we set the function equal to 0 and solve for x. X squared minus 9 equals 0. Add 9 to both sides to get x squared equals 9. Taking the square root of both sides, we get x equals plus or minus 3. So the x-intercepts are the points negative 3, 0 and 3, 0. Our third example is a square root function. Consider h of x equals the square root of x plus 2. First, let's note that the domain of this function is x greater than or equal to negative 2, since we can't take the square root of a negative number. To find the y-intercept, we evaluate h of 0. H of 0 equals the square root of 0 plus 2, which equals the square root of 2. So the y-intercept is the point 0, square root of 2, which is approximately 0, 1.41. To find the x-intercept, we set the function equal to 0 and solve for x. The square root of x plus 2 equals 0. Since the square root is never negative, this equation is only satisfied when the square root equals exactly 0. So x plus 2 equals 0, which gives us x equals negative 2. The x-intercept is the point negative 2, 0. This is also the starting point of our function due to the domain restriction. Our final example is a rational function. Consider k of x equals 1 divided by x minus 1. This function has a vertical asymptote at x equals 1, where the denominator equals 0. To find the y-intercept, we evaluate k of 0. K of 0 equals 1 divided by 0 minus 1, which equals 1 divided by negative 1, which equals negative 1. So the y-intercept is the point 0, negative 1. To find the x-intercepts, we set the function equal to 0 and solve for x. 1 divided by x minus 1 equals 0. A fraction equals 0 only when its numerator is 0, but the numerator here is 1, which is never 0. Therefore, this function has no x-intercepts, meaning it never crosses the x-axis. Let's summarize what we've learned about intercepts. The x-intercepts are the points where the graph crosses the x-axis, and we find them by setting the function equal to 0 and solving for x. The y-intercept is the point where the graph crosses the y-axis, and we find it by evaluating the function at x equals 0. Here's a quick recipe. For the y-intercept, evaluate f of 0 to get the point 0, f of 0. For x-intercepts, solve the equation f of x equals 0, and each solution x sub I gives an x-intercept at the point x sub I, 0. Understanding intercepts helps us sketch graphs quickly and provides important information about the behavior of functions. For example, x-intercepts tell us where a function equals 0, which are often important in real-world applications. Thank you for watching this video on x and y-intercepts. These concepts are fundamental to understanding function behavior and will help you in your mathematical journey. Practice finding intercepts for different types of functions to strengthen your skills. Remember, intercepts are just one of many important features of functions that help us understand their behavior. In future videos, we'll explore other key characteristics like domain, range, asymptotes, and more.